When you look up at the night sky, you see stars, thousands of them, twinkling like cosmic diamonds scattered across an infinite black canvas. Beautiful, right? But here's something that'll blow your mind. Everything you see up there, every single star, every constellation you've ever admired, represents less than 0.00001% of what's actually out there. And I'm not exaggerating. What you're looking at is basically nothing compared to the true scale of our universe. And recently, scientists discovered something so shocking, so absolutely mind-blowing, that it forced them to completely rewrite what they thought they knew about our cosmic neighborhood. They found out that we've been missing 90% of the galaxies in the universe. 90%. Just gone. Invisible. Hidden from us this entire time. So the question is, how did we miss 2 trillion galaxies? Where were they hiding? And more importantly, what else are we still not seeing? Stick around, because what I'm about to reveal will change the way you look at the night sky forever. And trust me, by the end of this video, you're going to question everything you thought you knew about space. Let's dive into this cosmic mystery. So here's the thing. When we stare up at the stars, we think we're seeing the universe, right? Wrong. We're seeing a tiny, ridiculously small fraction of it. It's like looking through a keyhole and thinking you've seen the entire mansion. And this doesn't just apply to what you see with your naked eyes. Even our most powerful space telescopes, even the massive observatories we've built on Earth, they're all looking through that same cosmic keyhole. But why? Why can't we see everything? Well, the answer is actually pretty simple, but also kind of terrifying. Light takes time to travel. And I don't mean a few seconds, like when you flip a light switch. I mean billions of years. The light from distant galaxies has to journey across unimaginable distances just to reach our eyes or our telescopes. And here's where it gets wild. Scientists assume the universe is isotropic. Now, I know that sounds like some complicated jargon, but it just means that no matter where you are in the universe, no matter which direction you look, everything looks pretty much the same. There's no center, no edge that we can point to and say, that's where it all ends. So because of this, we exist inside what's called a cosmic sphere. Think of it like a bubble. Everything we can possibly observe exists within this bubble, and the edge of that bubble is called the observation horizon. Now here's the kicker. The universe started with the Big Bang about 13.8 billion years ago. So you'd think, logically, that we can see 13.8 billion light years deep into space, right? Wrong again. And this is where your brain might start to hurt a little, but stay with me because this is crucial. The universe isn't static. It's not just sitting there, frozen in time. It's been expanding ever since the Big Bang. Constantly, relentlessly. And as it expands, the distances that light has already traveled get stretched out. So even though the universe is 13.8 billion years old, the actual distance to our observation horizon is a whopping 46.3 billion light years. Let that sink in for a second. 46 billion light years. That's the edge of everything we could ever possibly see. And here's the truly mind-bending part. Whatever exists beyond that horizon, we will never, ever know. Not in a million years, not in a billion years. Never. It's forever beyond our reach, locked away in the great cosmic unknown. Now, before you click away, drop a comment right now and tell me, does this terrify you or excite you? Because honestly, it does both for me. The idea that there's an entire universe, maybe infinite universes beyond what we can ever observe, it's both humbling and absolutely spine-chilling. All right, so let's talk about distance for a second, because this gets even weirder. The most distant objects whose light we can see today, the ancient galaxies that the Hubble and James Webb telescopes have captured, they were only about 40 million light years away from us when they first emitted that light. But today, because of the universe's expansion, they're over 46 billion light years away. Think about that. The light we're seeing now is from a galaxy that was relatively close to us billions of years ago. But by the time that light reached us, the galaxy itself had moved incomprehensibly far away. We're literally looking at ghosts, ancient echoes of objects that are now so distant, we can never know what's happening to them right now, in this very moment. So what does this mean? It means scientists can only speculate, only guess about what lies beyond our observable universe. And honestly, that's frustrating, right? We're curious creatures. We want to know everything. But the universe has set a hard limit on what we can ever discover. But here's what's crazy. The fact that we know this at all, the fact that we figured out there's a limit to what we can see, is actually remarkable. Because if we rewind the clock just 100 years, scientists had a completely different view of the cosmos. A view that was so wrong, it's almost embarrassing. Back in the early 1900s, even the brightest minds, even Albert Einstein himself, believed the universe was eternal and unchanging. They thought it had always existed in the same form, static and permanent. And get this, they also believed the Milky Way was the only galaxy in the entire universe. Can you imagine? The entire cosmos reduced to just our galaxy. Everything else? Just clouds of gas and dust floating around inside our galactic home. But then came a man named Edwin Hubble. And no, not the telescope, the actual person the telescope was named after. In the 1920s, Hubble decided to take a closer look at these mysterious spiral nebula, these fuzzy patches of light that astronomers assumed were just gas clouds within the Milky Way. And what he discovered changed everything. Inside these so-called nebula, Hubble found special stars called Cepheids. These stars are like cosmic lighthouses because their brightness fluctuates in a predictable way, and that brightness is directly related to how far away they are. By measuring these stars, Hubble calculated the distance to the spiral nebula and realized something shocking. They were way too far away to be part of the Milky Way. Boom. Overnight, our understanding of the universe exploded. Those nebulae, they were entire galaxies. Billions of stars, just like our Milky Way, scattered throughout the cosmos. We weren't alone. We weren't the center of everything. We were just one galaxy among countless others. But Hubble didn't stop there. He also noticed that these galaxies were moving away from us, and the farther away they were, the faster they were moving. Now, this wasn't because the galaxies themselves were flying through space like rockets. No, it was space itself that was expanding, stretching like a balloon being inflated, pulling galaxies apart. And this discovery, this realization that the universe is expanding, led directly to the Big Bang Theory. If the universe is growing, that means it was once much smaller. And if you rewind far enough, everything in the universe, all matter, all energy, all of space itself, was condensed into an infinitely small point. Then, 13.8 billion years ago, bang, the universe began. Now, before we go any further, if you're loving this cosmic journey and want to feed your curiosity even more, smash that subscribe button and join the Curiosity Beast family. We're uncovering mind-blowing mysteries like this every single day. Don't miss out. All right, so after Hubble's discoveries, scientists knew the universe was filled with galaxies, but they had no idea how many. Their estimates were mostly guesses, based on the bright, easy-to-see galaxies. All the faint, distant ones, they were invisible, hiding in the darkness. So in 1995, the Hubble Space Telescope did something incredible. It pointed at a tiny, seemingly empty patch of sky, no bigger than a grain of sand held at arm's length, and stared at it for 10 straight days. And what it saw was absolutely stunning. That tiny patch of empty space contained over 3,000 galaxies. 3,000! Some of them were 12 billion light years away, meaning we were seeing them as they existed just a billion years after the Big Bang. This image, called the Hubble Deep Field, revealed that the universe was far denser, far more crowded with galaxies than anyone had imagined. But scientists didn't stop there. In 2004, they created the Ultra Deep Field, going even deeper. Then in 2012, the Extreme Deep Field pushed even further, revealing galaxies over 13 billion light years away. Using these images, astronomers calculated the galaxy density and extrapolated it across the entire sky. Their conclusion? The observable universe contains somewhere between 100 and 200 billion galaxies. That number stood for years. 100 to 200 billion galaxies. Mind-blowing, right? Except it was completely wrong. In 2016, a team of scientists led by Christopher Consilish from the University of Nottingham decided to recount. They took all the Hubble Deep Field data, combined it with images from other telescopes, and created a three-dimensional model of a section of the universe. And using advanced mathematical models, they calculated how many galaxies we simply couldn't see. And the result? Absolutely shocking. There aren't 100 billion galaxies out there. There aren't even 200 billion. There are at least 2 trillion galaxies in the observable universe. That's 10 times more than we thought. 10 times! Let me say that again, because it's so insane. We missed 90% of the galaxies in the universe. 90%! They were there the whole time, just too small, too faint, too old for our telescopes to detect. Christopher Consigliere himself said, and I quote, "It's just incredible that more than 90% of the galaxies in the universe have yet to be explored. Who knows what exciting properties we will find when we explore these galaxies with future generations of telescopes." Now drop a comment right now. Do you think there's even more out there that we still haven't found? Because honestly, I wouldn't be surprised if that 2 trillion number is still way too low. So why did we miss so many galaxies? Well, most of them are dwarf galaxies, small, ancient, and incredibly faint. They're like the cosmic equivalent of trying to spot a single candle flame from across an entire city. They're out there, but they're just too dim for our current technology to see clearly. Scientists believe that in the early universe, there were actually more galaxies than there are today, but they were much smaller. Over billions of years, these smaller galaxies merged together, colliding and combining to form the massive galaxies we see today, like our Milky Way. So the total number of galaxies has actually decreased over time, but the ones that remain are much, much larger. At least, that was the theory. Until the James Webb Space Telescope came along and flipped everything on its head. Again. See, scientists assumed early galaxies were small and took billions of years to grow. But James Webb has been peering into the most ancient corners of the universe, looking at galaxies that formed a few 100 million years after the Big Bang. And guess what? Some of them are already as massive as the Milky Way. How is that even possible? According to everything we know about physics, there wasn't enough time or enough matter back then to build galaxies that big, that fast. But there they are, staring back at us through the Webb telescope, defying our understanding of cosmic evolution. So what does this mean? It means we still don't understand the universe as well as we think we do. It means our models, our theories, everything we've built our knowledge on, might need to be completely rewritten. And honestly, that's the most exciting part. Because every time we think we figured it out, every time we think we understand how the universe works, it throws us a curveball. It reveals something new, something unexpected, something that makes us question everything. And that's what keeps us searching. That's what drives astronomers to build bigger telescopes, to look deeper into space, to push the boundaries of what's possible. Because out there, in those 2 trillion galaxies, in those hidden cosmic worlds we've only just begun to explore, there are answers waiting. Answers to questions we haven't even thought to ask yet. So here's my final question for you. If we've already missed 90% of the galaxies, what else are we missing? What other cosmic secrets are hiding just beyond our reach, waiting to be discovered? Think about that the next time you look up at the stars, because what you see is just the beginning. The universe is so much bigger, so much stranger, and so much more incredible than we ever imagined. And we're only just starting to scratch the surface. If this video blew your mind, do me a favor. Hit that like button, drop a comment with your thoughts, and subscribe to the Curiosity Beast so you never miss another mind-bending video like this. Because trust me, we're just getting started. Thanks for watching, Curious Beast. Until next time, keep questioning, keep exploring, and never stop feeding that curiosity.